yy is equal to 810 times 10 to power 810.667 times 10 to power minus 9 plus by 8.574 times 10 to power minus 9. So this will become 810.667 plus by 8.574, 819.241 times 10 to power minus 9 meter 4. Okay. So the next one we are going to look at is your IZZ. Okay, so let me copy this entire image again. Okay, so let me so now we are going to determine our IZZ. So again, let me sketch very quickly. This is our image now. The axis of interest is now what? It's now your ZZ axis. So when this is the case, this will be the width. And over here, this will be our depth, because the depth is perpendicular to our axis. So let me draw the depth is in this orientation, because it is what? Perpendicular to our axis. So from here, you have to take note now. So if we were to address this as our flange, and this is our web, you have to be careful, because the centroid of the flange, which I'm going to draw in red, is offset from the global centroid. So this is our global centroid, about IZZ axis. This is the flange centroid. So when that's the case, the formula change a bit, yes or no? You all can remember. So the formula is equal to, so I just write the formula. So if we're going to do IZZ is equal to width depth cube over 12 plus by the cross-sectional area about, then this will be y bar minus small y bar squared. So big Y bar is the global centroid distance, and small Y bar is the individual centroid distance. And both of them, okay, are from a reference location. Okay, the reference location can be either at the top or at the bottom. Okay, so let's calculate IZZ then. So IZZ, because the flange at the top, so this is the flange at the top, the flange at the bottom are symmetry. So we can have IZZ is equal to twice again. So our width, okay, so our width now is 80. Our depth now is 9.5 cube over 12 plus by the cross-sectional area. And the centroid distance is what? 120 plus by 9.5 twice. So 120. So 120 plus by 9.5 plus by 9.5. So it's equal to, so this I need another bracket. So it's 120 plus by 9.5 plus by 9.5. Then the whole thing divided by 2. Yep. Then minus by 9.5 divided by 2, and the whole thing squared. Okay, and then we have another giant bracket. So this will be equal to 2 multiplied by 80 times by 9.5 power 3 divided by 12. 5.716 times 10 to the power of 3. Let me do it again. 80 times by 9.5 power 3 divided by 12. Yep. Plus by 120 plus by 9.5 plus by 120 plus by 9.5 plus by 9.5 divided by 2 minus by 9.5 divided by 2, squared the whole thing, times by 80 times by 9.5 is equal to 318.635 times 10 to the power 3. Okay. Let me calculate again, please. Hey, syntax error. I know. Okay, I'll be quick, okay? 3.186, 3.8. I got 3.186 the second time. What do you get? Wait, 9.5 120 plus 9.5 plus 9.5 divided by 2 minus by 9.5 divided by 2. Square the whole thing times by 80 times by 9.5. 3186 times 10 to the power 6. Okay. So this will be equal to 3.186 power of 6 plus by 5.716 power of 3 times by 2 is equal to 6.383 times 10 to the power 6 millimeter 4 or 6.383 times 10 to the power minus 6 meter 4. Okay. Let me know if I run out of time. Okay. So this is for our IZZ for our flange. Can you put in here as flange, please? So next we determine our IZZ for our web. Now our IZZ for our web, we only need to do what? BD cube over 12 because the global centroid and the individual centroid are the what? Are the same. Okay, so for the case, this case is width is 120, the depth is 9.5 cube divided by what? 12. So 120 times 9.5 power 3 divided by 12 is equal to 8.574 times 10 to the power 3 millimeter 4 or 8.574 times 10 to the power minus 9 meter 4. So therefore, IZZ will be equal to 6.383 times 10 to the power minus 6 plus by 8.574 times 10 to the power minus 9. So this is equal to 6.392. My answer is not the same as my notes. Hold on. With. Ay. No one stop me. Really? Not 120. With depth, yeah, it's 120. I do apologize. Yeah. 9.5 times 120 power 3. I do apologize. My bad. It's 1.368. Why did I do that? So times, can you change that, please? So this will be equal to 1.368. $6.383 plus by 1.368 is equal to 7.751. Okay, so we are going to compare. So note that IYY is equal to what? We calculated IYY earlier. IYY is 819.214. 819.214 times by 10 to the power 9 meter 4. And IZZ will be equal to what? 7.751 times 10 to the power minus 6 meter 4. Okay. So when that's the case, buckling will occur in the IYY, or not, so you don't call it IYY. So if we were to calculate IYY, okay, so IYY, if we go back here, right, we go back to the beginning. So this is IYY. So buckling will occur in the what plane? XZ plane. Okay, so buckling will occur in the XZ plane. Okay, so now we have to use the IYY formula. So therefore, P critical is equal to pi squared EIYY over by our L squared. Okay, so this will be equal to, so pi squared, Young's modulus is 200 times 10 to the power 9. Second moment of area is 8.1, and not 8.19, 819.214 times 10 to the power minus 9 divided by the L squared. So the length is 6 squared. So this is equal to 200 power 9 times by 819.214 power minus 9 times by shift pi twice divided by 36. It's equal to 44.92 or 918 times 10 to the power 3 Newton. Okay, so that's your critical. Therefore, factor of safety will be equal to P critical over P. So this is equal to 44.918 times 10 to the power 3 divided by the load. The given load is how many? 16. Or the applied load is 16. So 44.918 divided by 16 is equal to 2.81. Now, if we were to consider the other plane, the XY plane, right? The P critical will be equal to, so pi squared 200 times 10 to the power 9 multiplied by 7.751 times 10 to the power minus 6, and then we divide the whole thing by 6 squared. If we were to consider the other orientation, just to let you see, times by 200 power 9 times by shift pi 1 times by shift pi twice divided by 36. The load that buckling will occur will be 424.996 times 10 to the power 3. Okay, so in the other plane, buckling will occur much later. The load is much higher. So you pick the what? We pick the lower load. Okay, we pick the lower load. Or we pick the lower second moment of area. Okay, so at the end of the day, okay, when buckling occurs, buckling will occur in this orientation like this. Okay, that is the orientation that will occur. Okay, right. I will see you guys in an hour's time later.